The man responsible for the Golden Gate Bridge has already calculated what it would cost to replace it. Not because he plans to, because he cannot guarantee he won't have to. The bridge has a 72% chance of experiencing a major earthquake before the work keeping it standing is finished. The retrofit designed to protect it has been running for 35 years. The most important part started last year. His name is Dennis Mulligan. He runs the district that owns the bridge, and the words he chose on camera in public were these: "The bridge is safe. It will not collapse. No one will die on the bridge. However, there will be significant damage that will necessitate potentially having to replace the bridge. Replace it." The most photographed bridge in the world. A man whose entire job is to reassure the public said out loud, that one earthquake could mean tearing it down and starting again. And then he went back to work, because the work is not finished. To understand why, you have to understand where the bridge actually sits. San Francisco is built on the seam between two of the most dangerous fault lines in North America. The San Andreas runs along the Pacific coast just west of the city. The Hayward Fault runs through the East Bay, directly under neighborhoods where millions of people live. Either one can produce a magnitude 7 or greater earthquake. The United States Geological Survey puts the odds of a major quake hitting the Bay Area in the next 30 years at 72%. The Hayward Fault alone has a 1 in 3 chance of rupturing in that window. The Golden Gate Bridge sits between them, not near them, between them. It opened in 1937. For its first 50 years, it was lucky. And then, on the 17th of October, 1989, the luck was tested. The earthquake struck at 5:04 in the afternoon. Magnitude 6.9. The epicenter was 60 miles south of the Golden Gate, near Santa Cruz. It hit during the live television broadcast of the World Series, which is the only reason most Americans remember what happened next. Cameras that had been pointed at the field were suddenly pointed at the sky. The picture shook and went black. When the broadcast came back, the story was no longer the game. It was the Bay Bridge. A 50-foot section of the upper deck had broken loose and fallen onto the lower deck. One driver was killed. Whole neighborhoods in the Marina District were on fire. A double-decker freeway in Oakland had pancaked, crushing the cars beneath it. 63 people died that afternoon across the Bay Area. The Golden Gate Bridge, 60 miles further from the epicenter, came through with no significant damage. Engineers walked the deck the next morning expecting to find cracks. They found almost nothing. It would be comforting to say that proved the bridge was strong. It didn't. The Golden Gate had not survived because it was built to survive a quake like that. It had survived because the shaking that reached it was weaker than the shaking that hit the Bay Bridge. Distance saved it. Not design. A closer epicenter, a different fault, a few seconds of harder ground motion, and the most famous bridge in America would have been in the same headlines as the Bay Bridge. So in 1990, the year after the quake, a decision was made. The Golden Gate Bridge would be fully retrofitted to survive a major earthquake. The plan was divided into 4 phases. The work would be done while the bridge stayed open, while 40 million vehicles a year continued to cross it. That decision was made 35 years ago. Phase 1 did not begin until 1997. 7 years of studies, designs, environmental reviews, and funding fights before a single bolt was tightened. Phase 1 covered the Marine Approach Viaduct on the north side. It finished in 2002. Phase 2 covered the South Approach and the Fort Point Arch, the steel arch that lets the bridge pass over the historic fort on the San Francisco shore. It finished in 2008. Phase 3. A covered the North Anchorage housing and the Marine Towers Pier. It finished in 2014. 24 years. 3 phases. Every part of the bridge except the parts everyone recognizes. Phase 3. B is the heart of it. The main suspension span. The 2 main towers. The side spans. The parts of the bridge that everyone in the world recognizes. The parts that hold it up. The contractor for Phase 3B was hired in March of 2024. The work is not expected to be complete until 2029 at the earliest. 39 years from the decision to the finish line if nothing slips. And things have slipped before. Now here is the part the public has never been told clearly. The 2 main towers of the Golden Gate Bridge are not bolted to their foundations. They sit on them, by gravity alone. When the bridge was designed in the 1930s, the engineers did the math the way engineers did math in the 1930s. They calculated the weight of the towers, the weight of the cables, the weight of the deck and the wind loads the structure would have to resist. They concluded that the downward force was so enormous that nothing short of an act of God could lift the towers off their bases, so they didn't bolt them down. They machined the steel of the tower legs to sit flush against the steel of the foundation plates, and they let gravity do the rest. For wind, it works. For traffic, it works. For the daily life of a bridge, it works. For an earthquake, it does not. Hassan Astana Assal, a structural engineering professor at the University of California, Berkeley, has spent years modeling what happens to those towers when the ground starts moving sideways. In a major earthquake, the shaking does not just push the bridge from one side, it rocks it. And when a tower rocks, or one side of its base lifts off the foundation while the other side presses down, engineers call this uplift. Professor Astana Assal described the motion in plainer terms. He said the tower would move like a drunk person, a 700-foot steel tower, carrying the weight of the deck, the cables, and the traffic above, rocking on its base in an earthquake, with nothing holding the lifted side down, except the hope that it comes back to where it started. The retrofit currently underway is designed to fix exactly this. New steel plates, new connections, anchors that will, for the first time in the bridge's history, physically tie the towers to the rock beneath them. The work is being done from the inside. The South Tower stands 1,000 feet offshore. Crews reach the inside of it by boat and by lift. They remove existing fasteners one at a time. They cannot disturb the stresses already in the structure, because those stresses are what is currently holding the bridge up. Every old bolt that comes out has to be replaced before the next one can be touched. While they do this, they are also stripping the original paint. The paint applied in the 1930s. The paint that is 68% lead by weight. Much of it is still on the bridge, and every square foot of it has to come off before the new steel can go on. And here is the moment to stop and notice something. The Bay Bridge, the one whose deck collapsed in 1989, was retrofitted, and then the eastern span was replaced entirely. A new bridge, new towers, new deck. It opened in 2013. The cost was $6.4 billion. The Bay Bridge got a new span. The Golden Gate Bridge. The one in every photograph of California, the one on the postcards, is still waiting for its towers to be bolted down. The bridge that was damaged was rebuilt. The bridge that got lucky was left until last. The current phase of the retrofit costs approximately $870 million. The estimated cost of replacing the Golden Gate Bridge, if it were severely damaged, is over $10 billion. The work being done right now is worth roughly 8 cents on the dollar compared to what a replacement would cost. 8 cents to bolt down the towers of the most iconic bridge in America. And it took 35 years to get to it. Phase 3B is currently underway. The towers are being worked on right now. Crews are inside them as you listen to this. The retrofit is closer to finished than it has ever been. And the Hayward Fault is overdue. The Hayward Fault runs for about 74 miles along the eastern side of San Francisco Bay. It passes directly under Berkeley, Oakland, Hayward, and Fremont. It last ruptured on the 21st of October, 1868. That earthquake was estimated at magnitude 6.8. It killed 30 people and was known for the next 38 years as the Great San Francisco Earthquake. Then 1906 happened, and history forgot about 1868. The Bay Area's population in 1868 was around 150,000. Today it is more than 7 million. The fault has not changed. The number of people living on top of it has. Geologists studying the Hayward Fault have found evidence that it ruptures, on average, every 140 to 160 years. It has now been 157 years since the last one. The work has a schedule, the fault does not. Engineers studying the region today have identified 8.3 as the maximum credible earthquake the Bay Area could experience. The retrofit, when it is finished, is designed to withstand that. When it is finished, not before. So go back to the words Dennis Mulligan chose. The bridge is safe. It will not collapse. No one will die on the bridge. However, there will be significant damage that will necessitate potentially having to replace the bridge. Read those sentences slowly. The first three are reassurance. The fourth is an admission. They are the same statement. A man telling the truth and softening it at the same time because both halves are part of his job. The bridge is safe. The replacement cost has already been calculated. Both of those things are true at once, and they will be true together until the day the work is finished, or the day the ground moves first. The Golden Gate Bridge is not a monument. It is a working structure held up by steel that was bolted into place in the 1930s, sitting on foundations its towers are not attached to, between two faults that have been quiet for too long. It is the most beautiful bridge in America, and it is the one they left until last. The retrofit will be complete in 2029, if the schedule holds. The Hayward Fault is overdue. The man responsible for the bridge has already done the math on what comes next. He did the math because he had to, not because he expects to use it, because he cannot promise he won't.